Welcome back to the boat sheet. We're following straight on from last video where we looked at synoptic charts and how to calculate wind speed. Today we're going to look at the movement of fronts and pressure systems so we can forecast weather a few hours ahead. As we did last time, the first thing to do is to go to black and white because this uncovers that really useful geostrophic wind scale, which we're going to use again, this time to predict the movement of fronts and low pressure systems. Now you might wonder why we need to be able to use these charts when meteorologists already do that for us. But the shipping forecast and the inshore waters forecast don't always look far enough ahead for us. And if you're going to go to an anchorage, you need to know that it's going to be safe the whole time you're there. And that's why you might need to be able to predict at least a few hours, maybe 12, 24 hours ahead of the latest chart available. In this example, we're planning to sail to Falmouth. When we get there, we're going to try and anchor outside the River Fal in a little bay just to the west, which is a very sheltered anchorage. But we need to know what the weather's going to do for the 2 or so days ahead, and that takes us, in our example, 1 day beyond the latest chart. We won't get close to being as accurate as the Met Men, but all we need to be able to do is get close enough using rules of thumb to allow us to make strategic decisions. In navionics, if we zoom out from this little bay showing the anchorage, that anchor marker will disappear. So I'm going to add a pin. And to do this, you simply select the sea area near where you're going to anchor, then select or click in the box at the top of the crosshairs, which in this case is showing the depth. That opens a sub-menu, pick marker, and then pick from the choice of all the different possible markers you can lay down. I've chosen Anchorage, and that will stay visible at all zooms, which makes it really useful. If we zoom in, we can see that the fetch is really small. That is, the distance the wind travels over the water before it reaches the boat at anchor is really small from anywhere from southwest or west-southwest right round through north to about northeast or east-northeast. This makes it very clear why this is such a popular anchorage. Zoomed out, we can see that the Lizard Peninsula does a pretty similar job. The fetch is still relatively small, with the wind anywhere from southwest or even south-southwest through north, right round to northeast, and then St Anthony's Head, which is just to the east of our anchorage, also protects us with the wind nearly east. The only dangerous bit is this arc from just north of east through south to just west of south. And there, the fetch is all the way from France, and the swell could get quite uncomfortable or even dangerous. In case you're new to boating, this is because the waves are created by the wind, simple friction of air touching water. The longer that friction has to create a wave, the greater the waves will be. So where there's a short distance over the water, the waves are very small and are harmless. Where there's a big distance, they're bigger. It's as simple as that. Looking at the synoptic chart, let's start by just dropping a pin over our anchorage so we can identify it. You can see that if we were to arrive at the time this chart is valid for, then looking at the isobars and allowing for a bit of flow towards the low pressure, we can see that we're going to have west-southwesterly winds. Using the geostrophic scale, as we did the other day, we get a geostrophic wind speed of 40 knots, which means that at the surface we're going to have wind speeds of around about 20 to 25 knots over water, and a wind speed of around about 15 to 20 knots over the land, and at night that will reduce to a wind speed of about 10 to 15 knots. By anchoring close to shore with the land to windward, we benefit from the wind speed being based on the land values and also a small fetch to the boat. However, we've got one other problem to worry about here, and that's this low pressure off to the west, that low at 976. We need to be able to see what that low is going to do and whether it's going to affect the safety and comfort of our anchorage. Now, we're not going to get even close to what forecasters do, and if you're a forecaster, please do forgive the gross inaccuracies and simplifications that are about to come up, but this is just rule of thumb stuff. What we're going to do is just roughly predict the passage of that low pressure system so we can see whether or not it affects our anchorage. Polar frontal depressions tend to move in the direction of the isobar closest to it in the warm sector between the warm front here and the cold front here. With no other factors at play, this depression would therefore move in a direction looking something like this. However, we've got another factor in play here. There's an even deeper low to the north-northwest, that low at 963. In this situation, there's a tendency for the secondary low, that's our low, to be swung around the deeper low in a cyclonic direction. In other words, in the northern hemisphere, anti-clockwise. In addition, warm fronts move slower than cold fronts, so as the system progresses to the east, the cold front catches up with the warm front and the two form an occlusion, which brings unsettled weather. We're looking at these in more detail in the next video. The direction this low is going to move in then will be somewhere between these two arrows, so let's just take the mean and say that that's close enough for government work. How fast it will travel is quite complicated, but we're anchoring, so we don't need to be that accurate. If we're anchoring overnight, we're there for maybe 12, 24, 36, 48 hours. Whether we're a couple of hours early or a couple of hours late doesn't really matter. That weather's going to arrive. We can measure the geostrophic force to start with using the isobars in the warm sector close to that low, and that comes out with around 66 knots. Multiplying that by 0.7 gives us 46, 47 knots. So in allowing a little bit for centrifugal force, we're going to be in the low 40s, so let's call it 42 to 45 knots. So our low is going to move along this magenta line at around about 40 to 45 knots, and we need to then measure how long it's going to take for it to arrive near us, which is a problem because scale is difficult on these charts. 1 degree of latitude equates to 60 nautical miles, so 10 degrees must be 600 miles. Here we see between 40 degrees north and 50 degrees north. Unfortunately, the gap between 50 and 60 degrees north is smaller because the scale changes on these charts as you move towards the pole. However, if we take a circle between 40 and 60 north, then it will average out any errors and we'll get a reasonable approximation of the radius needed at 50 north. Now, 600 divided by 45 is 13 hours 20 minutes. And of course, 600 divided by 40 knots would give us 15 hours. So we could approximate and say that this low pressure system is going to arrive at that circle at somewhere between 12 and 15 or maybe 16 hours. If I was going to estimate where this low would be after 12 hours when the next chart was produced, I would say it would be somewhere inside that circle and somewhere on that line. So let's just hazard a guess and say it's going to be 3/4, 4/5 of the way out, which puts it somewhere here. As we can see from this chart, I wasn't that accurate. However, I was accurate enough to tell that it wasn't going to be a good place in that Anchorage. Here we see the low has moved to somewhere around Land's End. The occlusion has formed and it is coiled around the low, and the cold front is catching up with the warm front, and that the two are forming an occlusion which is stretching across the northern half of Cornwall. More importantly, where our anchorage is, we can see that our winds in that point overnight will be very unpleasant, with the wind coming straight from the south across the sea, and this would have been a very uncomfortable or even dangerous place to anchor. Based on this prediction, even though it might not be that accurate, I would be looking for a better anchorage in a south or southeasterly blow. In this case, we have one very nearby. Just about 3 miles away from our anchorage at Falmouth, we have the Helford River. And it's no surprise that the Helford River is very busy in bad weather because it makes a really sheltered anchorage. I would tuck right up into the depths of this river as far as I could go, just where the two drying creeks are to the north and south there, and I would anchor somewhere up there so that I have protection in a wind all the way from just south of east, all the way round until just north of east. So whatever happens with that weather, we'd be safe, and we're only 3 miles from where we wanted to be. This is very rough and ready, and I'm not claiming that anything I've just told you is going to be accurate. However, it doesn't need to be accurate to help you with strategic planning. I hope you found that useful. As always, if you like what you see, please do subscribe to the channel. Please hit that like button for me. It really helps us get noticed by other people. And if you click the bell icon, you'll be notified the next time we put a video up on the boat sheet.